Now let's talk about inscribed angles. But before we can do that, we need to talk about a few different types of segments or lines that we need to create those inscribed angles. A chord is a segment connecting 2 points on a circle. So if, for example, we had point C here and point D here, and we draw a segment from C to D, that segment CD is a chord. A secant, on the other hand, is a line connecting 2 points on a circle. So if on this circle we have points E and F, and we draw a line that goes through these 2 points, and remember, lines go on forever in both directions, then this line, and similarly to the line we drew, the symbol above our letters also has those 2 arrows. Line EF is a secant of this circle P. And lastly, a tangent is a line intersecting a circle at one point only. And let me show you what I mean by that. And I'm going to draw something here. Don't draw this just yet, because that's not what our drawing is going to end up. Imagine I had this point T, and I have a line that goes to this point T. Now this is a line intersecting at one point, we think, but remember, lines go on in both directions forever, and if it continued, then it would intersect at another point, and then it wouldn't be a tangent, it would actually be a secant. So what does a tangent look like then? A tangent is a line that really only connects at one point, and what that really means, and that's also the meaning of the Latin word tangent, it really just touches the circle in one point. Tangent means touching, and this would be the tangent, and since we have to give it a name, let us just find another point on that line, and now we can say the line TN is a tangent. So looking at these 3 things, let's see some things that they have in common and some things where they're different. First of all, the chord and the secant, they look very similar from our picture, right? And the only difference between a chord and a secant is really a chord is a segment, a secant is a line. And you can even say the secant down here, EF, also contains the chord EF. We just take that piece that goes from E to F. So a chord is a segment, a secant is a line, but both connect 2 points on a circle. A secant and a tangent, they are both lines, but in which way are they different? The secant connects 2 points on a circle, while the tangent only touches at one point on that circle. Alright, so now we're ready to talk about inscribed angles. An inscribed angle is an angle where the vertex is on the circle. And here we also have a picture that shows us this. The angle LMN has M, its vertex, lying on the circle. And just like the central angles we discussed before, this inscribed angle creates an intersected arc on the other side. This is our intercepted arc. And now, what is the relationship between the intercepted arc and the angle that creates it? Remember, when we had our central angle, let's just assume we have point P here, that's at the center, and the central angle creates that same intercepted arc. We said that the measurement of the angle is the same as the measurement of the arc. Let's just assume this arc had a measurement of 80 degrees. If that were the case, then we know that the measurement of our central angle is also 80 degrees. Now look at our point M, and we see that the angle that we created, if we assume we take our P and we pull it towards the left until it's all the way at M, that angle gets smaller. And the vertex of that angle is actually twice as far away from the arc as the point P if it was a central angle. And therefore, the formula for the measurement of that angle is that the measurement of our inscribed angle is actually 1/2 of the arc. Not the same as the central angle, but 1/2. And again, one way to think about this is that the vertex is twice as far away, and that makes that angle half the size. Here is another formula that you need to remember from this lesson. Let's look at some examples. In these two examples, we're supposed to find the value of each variable. So what I want you to do with those inscribed angles is I want you to imagine this angle is like a flashlight that sheds light on some part of the circle, which is our intercepted arc, and I want you to use a highlighter and mark it like this. That helps you see which is really the intercepted arc. Our intercepted arc in example 8 is this arc, and we are being told that this arc has a measurement of 126 degrees. So what is x? X being the measurement of our inscribed angle. Well, x has to be 1/2 of the arc. So x is 1/2 of 126, and that is 63 degrees. Let's go to example 9, and let's again use our highlighter for the flashlight, and that shows us what the intercepted arc will be. The intercepted arc goes from B all the way to C. And we're not given either the measurement of the arc or the measurement of the inscribed angle, but both of them are expressions with a variable. We do know, however, that the inscribed angle has to be half the size of the arc. So let's set up an equation to solve this. 5x is equal to 1/2 times 9x plus 21. And as we go and solve this equation, we want to get rid of our fraction here. The fraction doesn't suit us so well. So let's multiply both sides by 2. And as we multiply by 2, the fraction goes away. So 10x is equal to 9x plus 21. Now that looks already way easier, right? Subtract 9x from both sides, and x is equal to 21, and we don't even have to go any further. That is our final answer. Let's move on to our next two examples. And again, we're supposed to find the variables. What is our inscribed angle here, and what is our intercepted arc? Our inscribed angle creates this intercepted arc over here. And we know that our inscribed angle has a measurement of 20 degrees. Now, we're not even supposed to find our arc BC. We're actually supposed to find our arc AB, because that is where our variable is. So how can we do this? Well, first we have to realize that we have some additional information given here. From point A to point C, we have a line that goes through the center P, and that line is a diameter. And if this is a diameter that goes through the center, that cuts our circle in two semicircles, and that tells us that this whole arc is actually a semicircle. That whole thing is measuring 180 degrees. So if we know what BC is, then we can also figure out what AB is. And BC we can find with our inscribed angle. And now we are ready to go. Remember, our inscribed angle is 1/2 of the arc. This time we have the angle given. So 20 is equal to 1/2 the measurement of arc BC. If we want to find the measurement of arc BC, we have to multiply both sides by 2. 2 times 20 is 40, and that is the measurement of arc BC. So the measurement of arc AB, which is equal to x, will be 180 minus 40, and that's 140, and that is the measurement of arc AB. So x is equal to 140 degrees. And on to our next example, number 11. Again, we have our inscribed angle, and the inscribed angle sheds light on this entire arc. And we know that the inscribed angle is 90 degrees. It's a right angle. I'm going to write our formula down one more time. The angle is 1/2 the measurement of the arc. 90 degrees is the measurement of our angle, and those 90 degrees are 1/2 of the measurement of the arc, which is shown to us as an expression 2x plus 10. Again, let's get rid of our fraction first. Multiply both sides by 2. And we have 180 is equal to 2x plus 10. Subtract 10 from both sides. 170 is equal to 2x. And now we divide by 2. And 85 is equal to x. And make that a degree, because we're talking about measurements of arcs. And here is your answer. Then let's talk about inscribed angles that intercept the same arc. We have angle C, and angle C intercepts and creates the arc AB, and we can show that with our flashlight. And let's assume that this arc has a measurement of 80 degrees. Then we know now that the angle C has to have a measurement of 40 degrees, which is 1/2 of the measurement of the intercepted arc. Now let's assume we have another angle that's an inscribed angle, angle D, and that intercepts at the exact same points A and B. And let's use a flashlight for that as well. If that intercepts the same arc that is still measuring 80, then we know that angle D also has to measure 40 degrees, and that is really the point about inscribed angles that intercept the same arc. They are congruent. That's the thing you need to remember about this, and it follows from just looking at those angles and those arcs. If it's the same arc that they're intercepting that has a certain measurement, then both angles also have to have the same measurement. And let's use this in an example right away. We have two arcs in first example 12, and again we have to find the value of the variable. So let's look at the angles and arcs we have. We have one angle that intercepts the circle, and with our flashlight we can see the arc that's being intercepted. And then we have another angle, and that intercepts at the exact same points and therefore creates the exact same arc. We don't know what either of these two angles measure, but we do have two expressions describing the measurement of these two angles, and those two have to be the same because they're congruent. So use that to set up your equation. 5x minus 2 is equal to 4x plus 9. So let's first subtract 4x from both sides. And we got x minus 2 is equal to 9. And now we're going to add 2 to both sides. And x is equal to 11. There you have it. if you take 4 angles and inscribe them, if you take 4 angles and inscribe them on a circle, you get an inscribed quadrilateral. And that means that all 4 vertices are on the circle. If you have an inscribed quadrilateral, then the opposite angles are supplementary. The opposite angles are supplementary. That is important to remember. And now, why is that the case? To understand this, let's look at the diagram we have here. We have angle F. Let's switch on our flashlight and we see the arc that's being created by this angle. This is our arc EDG. And then we have angle D, which is opposite of angle F. And angle D has its own flashlight that goes the exact opposite way and creates an arc that goes around this way. And if you look at both these arcs, you see that they cover the entire circle. Those 2 arcs cover the entire circle, and the entire circle has a measurement of 360 degrees, as we know. And since the 2 angles are inscribed angles, their measurements have to be half of each arc. Now, without even knowing the measurement of each one of these arcs or each one of these angles, we know that together the arcs measure 360. So together the angles measure half of that. That's 180 degrees. And that is what supplementary means. Let's work through an example using this. And again, we have to find the value of the variables, and we have 2 variables here that we're supposed to find. We have x and y, and x is part of the measurement of angle R being opposite of angle P. So we know that these 2 angles, R and P, who are opposite, also have to be supplementary, and that's what we're going to use to set up our equation. So 63 plus 3x has to be equal to 180. Subtract 63 from both sides, and you get 3x is equal to 117. Subtract both sides by 3, and you get x is equal to 39. Don't forget the degrees. And then we have angle S, which is opposite of angle Q. And again, therefore, they are supplementary. So angle S, whose measurement is 4y minus 1, plus angle Q, which is 65, have to add up to 180. First, let's clean up and combine like terms. On the left, we get 4y plus 64 is equal to 180. Now we're subtracting 64. 4y is equal to 116. Divide both sides by 4, and y is equal to 29 degrees. So much for that, and now go ahead and watch the last part of this tutorial, where we'll talk about angles in the interior and the exterior of a circle.